Now we introduce another interesting phrase mining algorithm called SegPhrase. It's phrase mining with tiny training sets. We have introduced the top mine. Top mine is mining phrases without any training data. However, if we have a small set of training data, it may substantially enhance the quality of phrase mining. This was done by Jialu Liu. He and his collaborators working on mining quality phrases from massive text corpus data, and they published their work in Sigma 2015, is as follows. If we have a raw corpus, if we use a small set of training labels by human, of course, later they extended to get a general knowledge base like Phrase or Wikipedia. But in this algorithm, we first just study, suppose we got a small set of labels by human, like 300 labels. Then we feed them into a mining process. We may be able to get a quality phrases and also get a segmented corpus. And the quality phrases and segment corpus can mutually enhance each other by phraser segmentation process. So finally, we'll be able to get a high quality phrases generated. So we look at the overall framework. And the overall framework, the first thing they introduced comparing with top mine is first do frequent pattern mining, feature extraction, but in the meantime, they introduce a classification process. The reason they introduced the classification process is because they have the labels. The label can, based on the feature extracted, the classifier will be able to say we can put more weights on the positive labels and put some negative ones, negative labels as a bad phrases. We will be able to work out a classifier. Okay, that means SegPhrase itself use a classifier. Okay, and small label data sets. These data sets could be provided by experts or by a distant supervised knowledge base like a Wikipedia or DBpedia. Okay. Then, if we look at a SegPhrase, it's doing phraser segmentation and phrase quality estimation. After that, they will go back and feed into this classifier again to get one more round to enhance the mine quality phrases. Okay, so that's why they call this one more round after phraser segmentation and phrase quality estimation to feed back to the classifier again as SegPhrase plus process. Let's look at how they do it. The first thing they did is doing pattern mining for candidate sets. That means using frequent pattern mining algorithm to get a candidate phrase sets. That means you mine frequent k-grams. The k, this essentially is a frequent phrases, but k is typically small. For example, 6 grams. Of course, for some other applications, like some biomedical applications, k could be even bigger. Okay. The popularity measure is by raw frequent words and a phrase mined from the corpus, this popularity. Then doing feature extraction based on the concordance. That means whether you partition the phrase into 2 parts and check whether the co-occurrence is significantly higher than the pure random. Okay. Then another feature extraction process is informativeness. That essentially is you assume the quality phrase typical start end with a non-stop word. For example, you say machine learning is, machine learning. Likely machine learning is a good phrase. Machine learning is. This is stop words, starting and ending with the stop words like this. Actually, it's a non-stop word, but it is a stop word. So you basically say this is not part of the phrase. And another method or heuristic is using average IDF. IDF is inverted document frequency over the words in the phrase to measure the semantics. Simply says, if this phrase is frequent almost in all the documents, across all the documents in the corpus, then this IDF is too high and it may not be very good quality. And if this phrase is actually occur more frequent in some documents but less frequent in other documents, it becomes more interesting, more distinctive. Okay. Then another heuristic the algorithm uses is consider the probability of quality phrase in quotes, brackets, or connected by dash or hyphen should be higher. For example, like a state of the art actually should be a phrase rather than thinking these are several different things. Okay. Then SegPhrase uses a classification process. It explores a tiny set of training data. Usually for gigabytes corpus, you just need to have 300 labels. What kind of label it is? For example, you may say super vector machine is high quality phrase. The experiment shows is not a good phrase. Okay? You just based on the quality, you give 1 or 0. Then we can construct models to distinguish quality phrases from the poor ones. And this classifier, actually in the method, it used random forest algorithm to boost different data sets with limited labels. You don't want using very small number of labels, then you miss coverage of the others. So the random forest usually give you less bias. Then phraser segmentation can tell which phrase is more appropriate. For example, you look at this one, you say a standard feature vector machine learning setup is used to describe or something. Actually, instead of thinking this, like if you say feature vector here is a good phrase in this particular one, the vector machine should not be combined, but machine learning should be combined. So that simply says when you rectify it, you will get you will not say vector machine actually got as the real count, but the feature vector is a good count and machine learning is a good count. Then we can partition a sequence of words by maximizing the likelihood and consider length penalty. That means you get too long, maybe it's not a very good phrase. Filter out phrases with low rectified frequency. Then if the process is a classification, then do phraser segmentation. That's part is the SegPhrase, the first round. Okay, and for putting plus, actually you feed this phraser segmentation process into classification again, then you do phraser segmentation again. This actually derive even better results. We call this one SegPhrase plus. Then we probably can see the experimental results. The data actually used was DBRP and YERP with millions of documents and tens of millions or hundreds of millions of words. But every time we just use 300 human labor phrases for training. And then for the phrase evaluation, we use a wiki phrase and sampled 500 times 7 wiki uncovered phrases result evaluated by reviewers. Okay, then you probably can see the result comparing with other algorithms, and you can see comparing to a few comparative algorithms. Of course, it may not be a very fair comparison if you think TopMine does not use any training at all. But anyway, we put it down there to give you a relative where TopMine is if we do not use any training data. So this is a precision recall curve for DBRP data using SegPhrase as a label to check it. And the second one is based on DBpedia, not using SegPhrase, but using non-wiki phrases. For the wiki phrases, you probably can see the difference is pretty high. Non-wiki phrases, the phrase result actually is you probably can see it's overall this method generates a very high quality comparing to the others. And also, SegPhrase algorithm is efficient, it's linearly scalable. So we look at some real results you can see. To mine from the titles and abstract of ACMC KDD, the KDD proceedings, you probably can see we just need the title and abstract, but using SegPhrase, and comparing with chunking method using TF-IDF and C-value. And these red ones are phrases only generated in SegPhrase plus, but not in chunking. Okay, these are red ones. And these blue ones are those generated only in chunking, but not in SegPhrase. But you probably can see in that case, you see like for KDD, time series, gene expression data, frequent subgraph, categorical attribute. These are very meaningful, good phrases for KDD. But if you look at the important problem, effective way, small sets, these are the data, the phrases almost appear anywhere, not just in KDD. So that means chunking method may not generate as high quality phrases as like SegPhrase plus. And the interesting thing is both TopMine and SegPhrase plus are extensible to mining quality phrases in multiple languages. For example, this is a Chinese language from the Chinese Wikipedia. And we can see these Chinese phrases are pretty high quality, is generated using SegPhrase. And it can mine Arabic language even without pre-processing. You can see the results, TopMine can generate those phrases without any training and pre-processing and generate some quality phrases as well. So in summary, we have studied pattern mining applications, mining quality phrases from text data. We studied why frequent pattern mining could be useful for phrase mining. We discussed the previous phrase mining methods. We introduced two new algorithms. One is TopMine, one is SegPhrase. And this is a set of references. Those published papers we have been cited and compared in our studies. Thank you.